Let's get started with Docker. Now, if you see the symbol of Docker, right? So if you see the symbol of Docker, this is the jellyfish actually, and these small mountains are nothing but this is the dockyard, right? Where the ships come for loading and unloading, right? And they'll take another containers and they'll go to another destination, right? Basically, it's a jellyfish loaded with the containers. And if you see, these are physical containers, right? You must have seen these are the containers used as a physical containers to carry the goods, right? From one destination to another, or might be from one country to another, or even one continent to another continent, right? So these are the containers. Now this is the symbol of Docker, right? Why we have symbol like this? There is a logical meaning to it. Now, what is the logical meaning? If you see these containers, right? So how they look like, right? If you see these containers, they look like that they are the standard in size, right? The shape and size is standard here, right? Each and every container is a very much following some standard, right? In the shape and in the size, right? And that is the reason here also in our Docker also we are going to have a standard container, right? In shape and size, right? Whatever we are seeing, but the content inside this container is right. Once you put the content inside this container, nobody is going to change it, right? Wherever I ship it, let's say I put some containers, some content inside this container, might be apparel, shoes, mobile phone, laptop, whatever, right? Wherever this container will go, right, people will receive as is, right? The way it has been loaded, the recipient at the other end, he will receive as is. So nobody can change the content inside the container. All right. So we are going to have a standard shape, size, and even the content inside the container. Once you package it, right, the content, all the content inside the container will remain as is intact, right? Nobody can change it, right? So that is how we will also imbibe the same logic, right, from these physical containers, right, in real life, the physical containers into our technology containers, right? What is this container? Today we'll understand it. So going ahead with Docker, let's begin with Docker. So why Docker? Right? So if I ask you, what was the problem? Why we need this tool and how this tool has introduced to fix that problem, right? So the use case is like here. So developer, let's say we have given some task to developer, let's say to build some website, right? So let's say learning portal, we want to create one huge catalog of learning website, and that is how these developers are building that website. All right. Now these developers, right? This guy has built the website and he is doing the testing on his own local machine where he's building the website. He did the testing and everything is fine. According to him, everything is working fine. So he claims that okay, my solution is ready and it works fine on my system. Right. Now this whatever the website has been designed by this guy, this developer. Right. Now the hosting team or the operating team, right? They want to deploy this website on a hosting environment, on a production environment, so that the whole world can access, right? So the whole world can start accessing this. This guy, when it deploys the website, it doesn't work on this system, right? So this guy say, okay, your code is faulty, it doesn't work on my system. This guy claims, okay, this works very much fine on my system. There is absolutely no problem. I tested my code and it's working fine. This guy says, okay, I picked up your code, I deployed your code, but it is not working. And what will happen? They will fight each other. These guys say, okay, no, my system, nothing is there, only I've deployed your code, right? That means the fault is on your code. These guys say, look at it, right? Whatever solution has been built, I have tested it, is working fine, right? And the fight will start between these guys, right? So now what Docker is going to offer the solution, right? So Docker gives the solution, right? What is the solution, right? Might be this guy's environment and this guy's environment may not be same, right? Might be the prerequisites, this guy have not understood the prerequisites, right? Might be this guy has not given the full details of the prerequisite that okay, you have to install so and so thing and then deploy my solution, then it will work, right? So there might be some gaps. So Docker is going to take care of all that thing. So what Docker is going to do? So basically this is a container, right? What is container? Container is an empty vessel, right? If I take a physical container we use to store something in our uh, containers, right? Might be rice or might be anything, right? So container is an empty vessel, right? Where we store whatever we want to store. We just need an empty vessel so that we can store our things. So this guy, when he build the solution, right, what we give him an empty container, right? So whatever the solution these guys build, we put everything into that container, right? So we put everything into that container. That means what was the operating system on which the solution has been built, we will capture the snapshot of operating system also, right? What software he has used to build the website might be PHP, right? So we will have the PHP software also. We have a snapshot of PHP software, so that during runtime, right, the code should be run through the PHP. It needs a PHP environment, so we'll provide the PHP environment, right? So the PHP software is there, and his PHP code is also here, right? So whatever code has been built on top of the PHP software, the code has been, we have packaged the entire code, and the code is also put inside the container. And then this guy must have used some third-party libraries also for designing or for graphical interface or for any other visualization, right? He might have used some third-party libraries as well. That also we will take and bundle everything into this container. All right. Now in this container, I'll put a wrapper. Wrapper means I'll cover this thing and package everything as a single bundled solution, right? Which has everything, right? From the OS, prerequisites, third party, right? Main application, software, code, everything I'll package into it, right? And so basically this is my container having everything. Now once I put this container and I ship this container to anywhere, right? So I have packaged it. If I want to distribute it, I send it to UK, US, Middle East, India, wherever, right? Whoever will get this container, my code will 100% will work this time, right? Because last time, right, we gave the code and only the code, right? And the other guy, the hosting guy or the operations guy, were not able to run the solution because the other things were missing. Now what we have done, we have packaged each and everything, right? We have packaged the entire environment, right? And that is how we are going to bundle each and everything into a container. So container is just an empty vessel, put everything into it, right? And package it, right? As a single installer kind of thing, right? So when we say package means having everything. And when I ship this package to anywhere, people at the other end, whoever is going to receive it, he will get my code as is, which has packaged everything. So my code which needs OS, which needs PHP software as a runtime environment, right? And then third-party libraries, everything is bundled together. My code will work 100%, absolutely seamlessly without any error. All right. So container gives an edge where you put everything into the container, right from the OS prerequisites, post configuration, main code, your the main application code, everything into it. Your application will work, right, 100%, right, without any dependency. And container means everything will come from the container. It will not ask you that, okay, give me the Java runtime installer I need it, give me that software to be installed, right, and then deploy my code and my code will work. It is not like that, right? So we are going to have everything. So that means the container itself is look like a virtualized environment. All right, virtualization we have been using for more than decades, right? So now, right, the container also on the periphery of the virtualization, we have created an entire solution and we are creating as a virtualized environment. Whoever wants to run, they can run it as this container. So everything is coming from where? From this container. All right, so everything is coming from this container. So that is the logical definition of Docker to going to fix this problem. And it should be always lightweight. It will not put everything into it, right? That we will understand next few slides as the architecture of the Docker. All right, so basically it's an empty vessel having everything, whatever is needed from my checklist from item number 1 to 10, and from 1 to 10 it is always needed to run my code. So we will package it all the 1 to 10 items into our container, and then wherever you ship it, right, we'll package it and we'll ship it, right? Everything is coming from my container. There's no dependency, there's no prerequisite, no configuration, no post installation steps, nothing. Everything is bundled together coming from the container. All right, so with the same ideology, we will start building our solution. Right now, this guy, whenever he build the solution, right, whatever the developer environment was there, right, so the same environment we have packaged into a container. And if I send the code into a container, and wherever this container will be deployed, might be in a production environment or a staging or a testing environment or a production environment, it will work as is, right? No fighting, right? There is no fighting between this guy and this guy. So this guy is able to run the code, right? Whatever this guy has built the solution, it will be run in any environment, maybe staging, testing, production, any environment. All right, so that is the philosophy behind this container. So we will begin with container, right? So who is going to bring this this platform? Who is going to offer this platform? Right, Docker. All right. So Docker, what is Docker? So if I define, so this is the official website, www.docker.com is the official website. What is Docker? So basically Docker is a computer software. All right. Docker is a computer software that performs operating system level virtualization, OS level virtualization. Right, virtualization we have been talking, right, from decades, but it is on top of it. And as I said, when you put all the things, your OS, your software for the runtime, your code which has been developed on that software, your third party libraries, everything you package together, right? So that is what we are going to do, right, as a virtualized system itself, right, which will come everything from that system, right? So my content itself is a virtualized environment, right? So here what we are saying, what is Docker? Docker is basically OS level virtualization, right? So it's a virtualization itself, but including OS. So it's a OS level virtualization, operating system level virtualization, and that is instead of virtualization, what we are calling containerization, right? So in the next slide, I'll draw a difference between virtualization, what technology we were using in virtualization, and now we are saying containerization, and we will compare, right? So we already have some picture in mind now, right? And then we will start building, right, our solution in a new platform, which we call as a containerization. All right, so just hang up for a while. We will deep dive with this definition, right? But in a short, containerization is nothing but a OS level virtualization. How you can virtualize your whole environment, including OS, right? That is what this Docker is going to do, right? And it's an automated thing. We need not to do anything manually. How? That we will learn, right? In next 10 minutes or so, we will learn. We'll start picking up the things and we'll build our knowledge around Docker. Alright, so Docker was released officially in 2013 by the vendor called Docker Inc. Right? Docker Inc. is the vendor, right? Apple Inc. is the vendor for iPhones, right? Same way this vendor. So what they did, they launched this tool by their own brand name, right? Because there was a company name Docker Inc. So they launched this software by their own brand name, right? And now this is so much popular, right? So it's almost around now 10 years. Right? The software came in the market around 10 years, but people started picking up the thing somewhere very late, right? 3 4 years just goes less, just like R&D, right? People take, they do R&D. Okay, what is new thing has come as a technology entrant in the market, and people start exploring and they try to embrace it. Okay, what kind of solution is going to fix? Okay, this is going to fix this kind of problem, let's explore it, right? But after 2016 or 2017, right, early 2016 and later 2017, right, it has started picking up market very very fast. All right, and that's the reason there are so many tools, right? Because once we see that okay, this is a fantastic platform it is going to offer, we start building, we start leveraging it into various other use cases, right? And that is how we did so much expansion, right? So much extension has been done on this particular platform. How? That we will understand it today. Okay, guys, please stay mute, right? Because the solution is this session is getting recorded. Sudhir, can you go mute? Thank you. All right, so that is how we will start build the solution. So virtualization we already know. Now a new definition, and it is expected also. Whenever we learn new tools, we also come across new terminologies. But don't worry, within few minutes we will come to know what is this new terminology called containerization. So Docker was released by the name of Docker Inc. Right? These are the vendor. They launched this product by their own brand name, right? And basically it is the software packages called containers or wrappers. Wrappers means put everything into a container and then package it put by putting a wrapper, right? If I want to serve you, right, if you have ordered something, right, let's say I'm running a online application and you have ordered something, let's say for food, right, we are delivering food and you have ordered something. We have 100 items in my menu, but you have picked a few items, right? You need some desserts, right? So you picked up some dessert. You need some main course item, you picked up some main course item. You need some Deserts also, you picked up some deserts. So starter, main course, and desert, right? So three items you have picked up from my menu. What I will do, how will I deliver? I will put each and everything into one box, isn't it? And I put a wrapper, right? And put it, right? And put your bill or whatever and stick it. And then the delivery guy will just pick that box and he will deliver it to you, right at the door. When he rings the bell, open the door, he will hand it over to you because you already made a payment. So he will just hand it over to you in next 20-30 minutes. He will hand it, so you will reach the parcel. And what you will get once you open the box, you will see, okay, this is what I ordered as my starter, this is my main course, this is my dessert. You will get it. But how you are getting, right? You have got everything put together in a box and put a wrapper around it so that we can ship it as a single package, right? So that is what we say here: containers, put a wrapper, put everything together as a software packages and package it by putting a wrapper. Right? Wrapper is nothing but bundle it, right? So we will bundle it into a single package, right? OS, software, third party libraries, right? Or my main source code, everything will package together into a single package, right? So that means we can, whatever is essentially needed to run my application, right? We'll package everything, right? As a single package, right? So that is what this container is going to do, and it's a new platform we call containerization. All right. So if you go and look for a Docker as an English dictionary meaning, right? If you go and look for what do you mean by Docker? So if you go and find the meaning in a dictionary, it goes like this: a person employed on a port to load and unload ship, right? Person employed in a port to load and unload the ship. That means when the ship comes, right, what you will load and unload? These containers. If something, some content destined for this location, it will just go and it will dump the container here. And if I want to send some content from this location to some other location, I will upload, right? We will load the container into the ship and the ship will carry this container to the destination. Wherever the ship is going, that container is destined, it will just go and it will take it, right? So loading and unloading is nothing but, right, we call, right, that is the job we do, right? So everything is flowing through container, right? Whether to receive the goods through the container or send the goods to the destination, other countries, right? We will put it in the container. So loading and unloading is the thing. So Docker is nothing but loading and unloading, right? Or in simple word, loading and unloading means what? I can say, right, download or upload. So wherever, whatever application I need, I'll just download on my system and I will start my application through the container. Or if I'm creating a customer solution for a customer, let's say we are working for IBM or Oracle, right? So what we will do based on the requirement, and we have the expertise, we won the project, we got the project. So my development team will build the solution, we'll package it and we will ship it. So we'll upload into their repository, they will start download and they will start deploying it. All right. So basically loading and unloading is nothing but load or upload, or I would say in simple word, push and pull. So we are using a push-pull technology here. So Docker is going to offer a push-pull mechanism. That means it is very easy, right? Whatever I need, I'll go to repository login and download it. Whatever I'm building solution, if I want to share with other people, right, other customer, right, I'll upload into that repository. So download or upload. So customer will download it. He will start using my whatever application has been built in container. He will start download the container, and he start running. Right? Download means download the package, we say image, right? Everything has been packaged into an image. He will download the image and run the container. All right. So download, upload is nothing but push pull, right? So we will talk more in a sense push pull mechanism. So it's going to be very simple, right? Push pull technique is a very simple and easy to go, right? So that is how we are going to use as a Docker, right? So Docker offers that. So it basically provides a uniform wrapper around a software package. How to provide this package? As I told you that we need a container and put everything and then put a wrapper or package it, bundle it so that we have all together, right, as a single bundle packaged, right? So how to do it? So basically what we do in a technology term, whenever you have a code, what we do a build, right? Build will package everything, right? What is there when you build the code? What is there inside my package? There might be some files, might be exe files, might be dll files, might be some configuration files, right? Might be some runtime files, might be some property files, right? All the files, right? So how we package it? By doing the build. Once you do the build, what you do? We ship it. It's a ready-made package has been created as a build, right? Package is created and then we ship it, right? So once you ship it, then you can run any application anywhere because everything is coming from that bundled package, right? Including everything right from the OS level, right? OS, right? My main applications software, my source code, my third party, my post configuration prerequisites, everything put together into a single package. And if I give you, and if I send it to anywhere, right? So you can run that solution anywhere, anytime, right? So that means once I package anything into a container image, and if I give you that container image, you can run anywhere, anytime. Because container, everything is coming from where? From the container. We are not expecting everything will come from outside the container, right? And that is why we have a resemblance to this physical container, that this container is going to give me everything, right? So that is how the Docker is going to give. And for more information, always refer to official link www.docker.com, right? There are tons of information available. Vendors try to sell their information. They say, okay, configure this way, this way, this way, and then install Docker, and my software will give this. So they are selling their product using Docker, right? So you will get confused, right? So always go to the official link so that you will get. And nowadays all the modern tools or softwares, they give huge documentation. So there's a huge information available already online. So always refer from the authenticated links, right? So in that term, www.docker is the official link, right? So this container, whatever we have discussed so far, is nothing but just like a shipping containers, right? The containers is always the same, right? As I said, the standard we are following, right? The size and shape will be always standard, fixed, right? So they looks like always same, and it is easy because we can ship it because the size is standard. Any ship, right, which comes, right, because of the standard size, my container will fit very easily because we are matching the standard, right? Shape and size is very different, then it will be a problem, right? So that is why if you see, they are very close, and one on top of another, another on top of another, like that, the stack of containers can put together very easily. So similar to shipping container, the container is always the same regardless of the contents, and thus fits on trucks or crane or ship wherever you want. It is very easy because of the shape and size. All right, so there are so many other benefits. So, and mobility also, we can ship it to any place by loading in. If the distance is short within a city, we'll put it on a container, right? Within the premises, if I want to put from my warehouse to my main production or my manufacturing plant, right, where my manufacturing unit is running, right, we use cranes. Or if you want to send for a larger location or a distant location, we use ship, right? So this is how we use these physical containers. Same way, we also use push-pull mechanism, right? We will introduce a centralized repository, and everything will manage through push-pull mechanism. If I need it, download it. If I have created and customized something, upload it so that other people can download and they can start. So that's the technique we are going to use in Docker. All right. Now let's jump to Docker and understand all the nuances, all the semantics, right? So we have now building our knowledge, right? Just the basic fundamental knowledge. Let's make it more strong by understanding the architecture, right? So let's focus on the architecture, what Docker is going to offer. So this white background is my, let's say, one virtualized machine, all right, or a physical machine, right? So this is one machine, and what we need, right? So to install Docker, so basically read this slide from the bottom. So what we need hardware. Hardware is nothing but a machine, right? So we need hardware, and hardware alone never works. So we need a OS, right, operating system, to operate that machine. All right, so we have to have an operating system, right? So we have a host operating system, right? The host operating system is the operating system running on that host machine, right? So the hardware loaded with OS. Basically, these are the physical machine configuration as a standard. All right, this is what we need as a standard. Now, what I install Docker, right? So when you install Docker, Docker comes with its own engine we call container engine, right? So we can say Docker engine, but normally it's a container solution, so we say container engine. So this container engine, right? And then what we do on that machine, you may install application one which you need, right? So you install application one, or maybe multiple application, right? So application two, or maybe another application three, right? So when we install so many things, right? We may have, right, we have a few application one, application two, application three, like that we install, and that is the basically default configuration of any machine, right? Whatever software I need, I'll install it. Maybe front and back end database, something, SQL database or anything, or Visual Studio or anything, right? We will install it. That is how we start working on that machine. Because if default softwares are installed on my machine, then it is very easy to work on my, right? I can start my work because I have all the required software, required environment in, right? Per se, what I'm saying, required environment is given, and on the required environment, I can start my work, right? So this is the basic architecture. We have hardware and OS as a basic requirement of a machine, any machine, physical or a virtual machine. And on top of it, I install Docker, which gives me a Docker engine, and then put your application 1, application 2, application 3, right? Now the crux here is when you install Docker, right? Docker act as a middleman, right? It act as a middleman between your application layer and your OS layer, right? This is my operating layer and this is my application. So applications are on top of my physical and OS machine. We have installed few applications. So Docker act as a middleman between your OS layer and your application layer, right? Now what happens is when you launch, for example, when you launch this application 1, right? What happens, right? So who will give you runtime environment and who will give you that environment where application 1 can be launched? Your OS. You need an operating system, right? What you need from operating system, few binaries and libraries which will help you during the launch of this application, right? So this application will kick start on its own and the environment is open. All right. So let's say if I want to run an MS Office, right? I want to create one Word document. What I will need, I need to install MS Office application, right? And my OS is already there, right? So when I double click on Word, right, Word icon, right, it will take few minutes, few seconds, and my application will be up, right? So in the background, what it needs few binaries and libraries to support this application to get launched, right? And who is giving this binary library? From the OS, operating system. That is the job of the operating system. Now this guy sits in middle. So what it does, it basically keeps track that okay, what all things are needed for this application to launch, right? So this guy will come to know, okay, only few binaries and libraries, because nowadays OS comes with so many things. OS has printer drivers, right? There is a huge list of printers, right? All drivers are there, right? Huge catalog of printer drivers, right? We do this application need during runtime? No, I may not need it. All the print drivers. There might be some scanners, right? There might be some other packaged things which I don't need it, right? Might be my mobile drivers, my printer drivers, or my some other scanners, right? Some plugins, I don't need it, right? To launch it, it's just a simple application to launch. Only few binary libraries I need, right? That means I don't need to load everything from the host machine, right? Printer, driver, plugins, I don't need it. Only required binaries and libraries are needed to support as a runtime environment and let this application kickstart. So when this application will be launched, this guy will keep track, right? At the very first time, he will see, okay, what this application needs. Okay, few binaries and libraries only needed, right? Now Docker is keeping tracking automatically because it is acting as a middleman. That is the role of Docker. So next time when you launch this application, this guy already knows. So what it will do, Docker will act as a local caching agent, right? It will take a snapshot of required binary and library and make it ready for you. Next time when you launch it, it will be very, very fast. Why? Because Docker is already acting as a middleman. It is acting as a caching agent for your application 1. So it knows that, okay, you need only few binary libraries and it will help you, right, to launch this application because it will just take a snapshot and acting as a local caching agent. Right? Same way when you launch another application, let's say today you want to work on some database application, right? So when you launch this your SQL server or through the SQL client you want to connect to your database. So what you need few binary library. You don't need all the plugins, right? All the drivers, right? You don't need it, right? So you need only few binary libraries. So Docker basically what it does, since it's a middleman, right? It's sitting on the top of OS, so it knows what your application needs. So when you launch on this application, this guy will come to know, okay, you need only few binaries and DLLs, right? Or few libraries to launch your application too, right? So this application. So next time when you launch it, this Docker will be ready with your required thing. It will help you to what all things are needed to support you to get kickstart, right? So this guy will give you all the binary required libraries and it will help you to get launched very fast. So basically it is increasing the performance also in the background. All right, it is ready with what environment you need for launch of this application. It is ready with it and act as a local caching agent, right? And your application will be very fast. It will come up very, very fast, right? Same thing goes with your application 3, right? So that means Docker is basically a middleman and it knows what all things are needed for your application 1 or application 2 or application 3. It will act as a local caching agent. So the communication between application layer and OS layer is maintained by whom? By Docker. All right, you need not to worry. So traditionally, if you look at it, when you launch the application 5 minutes or 3 minutes, you have to just sit idle, right? And but then application will be loaded. because in the background it is scanning and it is loading each and everything, and then it source each and every, it will start picking up, sourcing. Okay, I need this DL. Okay, I source me this file, this file, this file, this file, this file, and then your application will be launched. Right? And now that nowadays OS comes with so many things, right? They have come with so many inbuilt things, right? Git repository plugins are available, Python plugins are available, many things are there, right? So that your OS engine is powerful. You need not to look for anything. Though everything will be distributed as a distributed things from the OS itself, right? But here, who is doing? The Docker is helping you to launch the application very fast by acting as a local caching agent. All right, so Docker will come to know what all things are needed, only those things, right? It will be ready. Again and again, you don't need to scan the OS. Okay, give me this, where is this DLL, where is this binary, where is this library, right? You need not to do that. Docker will be ready with that, and it will act as a helping agent to launch your application very, very fast by acting as a local caching agent. How? That I'll talk in next slide. All right. So the middleman, who is the middleman? Your Docker. Right? Now let's compare, because we are saying Docker architecture is nothing but a containerization platform, right? It will containerize application, right? And into a container format, right? So container format is nothing but an image format, which will start building it very soon. But this is the crux. All right. Any questions, guys, here? Okay, no problem.
Docker image can be vary from image size can vary image by image.
Yes, to some extent. All right.
Okay.
Why?
Yeah.
Because probably next slide when I do, then I'll conclude that thing, what I mean to say. Right? So we have just started, and let me compare with virtualization. Then I'll tell you that Docker is going to give a lightweight solution. And because of the lightweight, the performance will always be very, very fast. Right? If your image is very, very heavyweight, you have bundled so many things, unnecessary thing also, because you don't know. Right? You are just assuming that this application may need this thing also. So you're putting the whole thing into it, and your application is heavyweight. Once the application is heavyweight, right, it degrades the performance eventually. So it has to be lightweight. Only required things you have to bundle. That's it. And who will help you? Docker will help you for that, because we don't know, right? But Docker knows it. He's a smart guy. All right. How? Let's jump to the next slide, right? No worries. You can ask me question later also, right? There's no hard and fast that you should ask me question only on this slide now, right? Not later. You can ask me later also. All right. Let's understand. So I'm comparing the Docker with the traditional methodology which we have been using as a virtualization. Right? We used to create a virtualized environment, and all my applications are running on a virtual hosting environment, right? So let's compare Docker with virtualization, and we have been using virtualization from almost more than decades. All right. So let's talk about. So this is the new way of Docker, which we just come up with the understanding of architecture, right? Now let's go with the virtualization, right? So this is called a new way. This is now we are calling as a old way, right? We are going to say goodbye Tata to virtualization. We have already reaped the benefit. We have been using more than decade. So we are not blaming, right? We are not blaming this is a bad guy, but we are just for the sake of understanding, we are just saying that okay, we'll go ahead with few more additional things, right? So virtualization doesn't give there are so many gaps that has been identified, and that's the reason the Docker has boomed up. It has taken up from there because it is addressing all the gaps. How? Let's understand it here. Now here again, to create a virtual environment, what we need hardware and a hosting OS, right? The operating system. So hardware operating, these are the standard for any machine. Wherever you want to deploy application, we need this kind of thing. So these are very basic. Now to create a virtualized environment, what we need hypervisory layer, right? So that we can create a virtualized environment for my application 1, virtualized environment for application 2, virtualized environment for application 3. All right, that is how we want to create a virtualized environment. So any application which you want to create, right, we want to create like this. So by enabling hypervisor layer, right, then we can create a virtualization. See, right? So if you know ESXi and all that thing, right, these are the virtualization layer before Windows 10. After Windows 10 and all that thing, it's already inbuilt, right? Because later we realize the benefit. So that is how we used to create, right, virtualized environment. Now here, if you see here, so when I want to launch this application, what we used to do to create a virtual environment for this application, we used to bundle the whole operating system itself, right? Because we never know what this application needs, which DLL, which binary. It was really difficult to get right to guess and put only those things. So it was really difficult. So and we don't have any mechanism, no software, nothing, right? So manually it is very difficult. So what we do, we used to bundle the entire operating system along with this application to create a virtualized environment, right? So when you launch this application one, everything will be picked up from the local copy of the operating system, which is available as a bundled software on top of the your application one, and it will support you to launch the application one from that local copy of the OS. And that is how we used to create a virtualized environment, right? Now here, right, we create virtual environment, and now same way, same thing in your application two, right? So when you create a virtualized environment, we used to bundle the complete operating system, right? And my virtualized environment for application 2 is ready. And when the application 2, when you want to launch, it will source all the required environment during the runtime from the local copy of the OS, which is available as a guest operating system, and this application will be launched, right? And same thing goes with the application 3. So that is how we used to create a virtualized environment, right? By bundling the OS. And if you see, there's a gap between application 1 and application 2 and application 3, there's a gap, right? If you see, there's a gap. The gap means basically this application 1 will be run in its own virtualized environment without having any interference with application 2 and application 3. They will not disturb application 2 and application 3. This will work as an independent virtualized application. Same when you launch application 2, there is a gap. So it will launch without any gap between application 1 and application 3. So this will also launch, right, just like that. All right. So same way in Docker also, there is a gap. I missed this point. So Docker also brings an isolation layer. It will not conflict with any other application which are already there on that machine. It will not conflict because Docker creates an isolation layer also. That means isolation means it will never conflict with this guy. Or when application 2 will never conflict with application 1 or application 3, it will run as its own isolation layer. Right? So same thing, virtualization was also like that, but to create a virtual environment, you have to load the complete operating system. Now, if I compare my Docker architecture with the traditionally which we have been using as a virtualization architecture, if I compare, right, if you see, this is lightweight, right, because here we have only one snapshot of operating system. We don't bundle operating system to create virtualized environment for application 1 or application 2 or application 3. Only the shared operating system is being used across all the applications which are there, because it's a local machine, so the same OS can be shared across all my applications. And who is giving the sharing thing? The Docker, right? Docker will source and keep a local copy, right? And it will help us. It will keep the local copy and it will help. It will take the copy and make a local copy here, and it long. And that is what I mean to say, local caching agent. It will already have in the local cache, and the application will be launched from the local cache, and the performance will be very, very fast. But here, if I look at it, right, it's very complex architecture, right? So the complete OS has to be loaded, complete OS to be loaded, complete OS has to be loaded, and nowadays OS comes in almost GBs, right? Earlier it used to come in 700, 800, 900 MB. Now we are added few more capabilities as OS level, and the OS itself comes now in GBs. So if you see, I have 4 instances of operating system loaded to create a virtualized environment. 4 OS are needed to create a virtual environment for application 1, application 2, application 3. Is it needed in Docker? No, right? Only single OS that is needed. But here the OS already there. On top of it, I need another 3 instances of OS. That means my cost will be very, very high here, because we need 4 licenses of operating system. So my cost is already 4 folds, right? It has increased to 4 folds, right? That is one. Another is, right, I need a high configuration machine, because then only I can create virtualized environment to give a required resources. Resource means CPU and memory, right? Let's say this application, I need 2 CPUs and 4 GB RAM. So again here, 2 CPUs and 4 GB RAM, 2 CPU and 4 GB RAM. So I need a high-end machine to create a virtualized environment, and that is how we were literally struggling to create a virtualized environment, right? Though we don't do directly, we have a team, right, network infrastructure team or infrastructure team or a support IT team who used to provide. But right, this was the thing, we need a high capacity machine. We upfront we have to do investment to have a multiple instances of licenses, and every year we have to renew it. So that means it's a recurring cost also, right? It's not only one time cost. Every year we have to upfront do some investments, right, at least to renew the licenses. But here, do I need all that thing? No. right? So if I compare it, this is slightly we call as a heavyweight virtualization. And to manage this kind of environment, we need a dedicated team, right? Which we call as a OS package manager, or we are relying on some dedicated infrastructure team who can support us. Here, who will do all the jobs will be done by Docker. We don't need anyone, right? So Docker, and that is the definition of Docker. What was the definition of Docker? OS level virtualization, isn't it? So we said here OS level virtualization because it will create the virtualized environment automatically by taking a copy of all the required things during runtime. Docker will understand it and it will be ready by sourcing those by keeping the copy as a local cache and itself will act as a local caching agent. All right, and that's the reason people start picking up taking the Docker because it's a cost optimized solution also. Now you must be thinking Docker must be very expensive. No, it is not, right? Docker also is like people are using as an open source, right? Docker has a two editions, community edition, which works as an open source. You need not to pay a single penny to anyone in this world. Directly go and download and start using it. Right? That is what even I will be doing it. Right? And another called enterprise version, right? So the community edition and enterprise edition, right? Enterprise edition is a paid version where you can purchase the AMC also and annual maintenance, right? So if you have any issues and you are implemented just Docker and you need support in production environment, you because your people are not yet trained, they are not highly skilled, right? They are just somehow running the show, managing the show. They are developers, right? So you can take the AMC. So Docker, you can raise a ticket with Docker, and Docker engineers will work on the tickets based on the SLA, right? And the severity of ticket, like simple, medium, complex, they have the SLA defines. For simple problem, they will address in few hours, right? Maybe one or 2 days, right? For medium, let's say 1 day. And for complex problem, within few hours, right? 4 hours SLA, and they will help you, right? So all that thing is available, right? It's not that expensive. So it's a cost optimized solution and performance increase very fast. And this is very heavyweight, right? So I have written few points here, very heavyweight, non-portable. Since very heavyweight, so I cannot take it, right, and push it somewhere. Very difficult, right? And we always have a dependency. We need some people who can support us. But here, right, it's a small weight. If I compare, 4 instances of OS are needed, right? But here we don't need it. So it's very lightweight, right? So since it's lightweight, so it will be very fast, right? And since it's lightweight, so it's very small also. I can ship it anywhere, right? So it would be very easy. Upload, download, or push pull is a very easy to handle Docker kind of container images. But here we cannot do that, right? So small, fast, portable, lightweight, and OS level virtualization. That is what this Docker is going to play the role, critical role. I need not to tell anything. By default, once you install Docker, it will start playing that role. So we don't need a dedicated team. Hey Docker, please help this application 1. Please help application 2. Hey, where are you, man? Please help application 3. Right? We need not to tell. It will do its job automatically because it itself has a OS virtualized layer inbuilt. All right, guys, right? So that is what I mean to say, right? So we are going to have everything and we will build our knowledge. We will start building knowledge to how to create virtual environment for application 1, application 2, application 3. And if you see, if I slice down here, right? If I put a knife and slice down, let's say this is a hot cake, and if I want to create 3 slices, right? If I slice it down here, it has everything. Application, binary libraries, Docker, host machine, hardware on which it is running, right? So complete piece, I take it out, it creates a virtualized environment. That is what we say, it creates its own virtualized environment. Docker will create a virtualized environment. And if I slice down here and here, I can take this piece out, then this has everything, right? Application 1, binary libraries coming from host, Docker is also available, right? Hardware and whole operating system also there, we can slice. And here also, that means we can create our own, right, virtualized environment. So Docker will help me to create a virtualized environment. That is why we say OS level virtualization, right? Because for virtualization we need OS, right? So that is what Docker is going to do it. All right. Now, right, we understood the Docker architecture, right? So let's understand how the architecture is offered in terms of layer, right? So basically this is my Docker architecture. When you install Docker, you will get 3 components, right? So your Docker engine, which we call Docker daemon, right? Docker daemon means services. It's a microservice based terminology. Microservice based architecture, we say daemon. Daemon is nothing but service, right? So we have to start the engine. That means you have to start service, right? So you must have worked on few Apache server or JBoss server or any server. You have to start the services. Once you start the service, that means the application engine will be started. And when the engine is started, it will automatically start working because the engine will take care of it. So here Docker also come with its own engine, and since it's a microservice based architecture, we say Docker daemon, right? So in short, we say Docker D. D means daemon, right? Or in short, for the layman's term, simple terms, I'll say Docker service, right? So you have to start a Docker service, and that is what our Docker engine, right? So this is the Docker engine, and we have a command line also. How we deal with Docker? To do any kind of job, we do through command line. So Docker has its own CLI. CLI means command line interface, right? It has its own CLI, and how it will right? So I will just give the instruction, right? It's just like a command. Do the command, and it has its own CLI, command line interface. So any day-to-day activities we do, we will do through command line. That means I need not to do any programming, right? In my demo session, somebody asked me, do we need any prerequisites to learn Docker and Kubernetes? I said no. Why? Because the coding is not needed here. So we are not going to do any programming, just few commands, right? And for that, we already have an interface, CLI, command line interface, through which we'll be doing all our day-to-day activities by firing few commands only. No coding, not even a single line of coding is needed, just few commands. All right. And then what, right? Who will do? The main job will be done by the Docker engine. So you just fire the command will be sent to Docker engine will do, collect the output and send it back. Who will do this job? There is a middleman called REST API, right? REST API we have been using as a inbuilt feature nowadays, right? You need not to do anything. If you customize some API, right? Every application has API. You can further customize, extend it, integrate it. One API can talk to another and all that thing, right? So I don't want to go into developers thing, but because of microservice-based architecture, right? Micro means a small piece of code, right? So we can do all the wonders, right? So this is the REST API, right? Guys, are you aware of REST API, or you want me to give some example to make you more understandable for this new term?
Please give example.
Okay, sure. For example, when you do Google, right? So let's say I want to search something. So what I do, I'll open the browser, right? And I just key in few words, right? The moment I hit the enter key, what it does, it takes my keyword and it goes to Google search engine and search in the Google search engine database. And based on the Google database has all the information, and it will source the information and publish information on my browser, right? Might be some links. Let's say I'm looking for some Kubernetes or Docker training, right? I'll just go and put some Docker training and thing, and it will pick up my keyword, right? And go to Google search engine, the Google search database, go there and query this keyword inside the database and quickly fetch the information, publish on my dashboard automatically, right? That means I need not to install the complete Google huge database on my laptop, right? To get the information from Google database, Google search engine database, I need not to install Google search engine database on my laptop. It is somewhere, I don't know where, right? Maybe US, some Google data center on which this search engine is running, or maybe UK, Middle East, India, I don't know where it is, right? What I need is only internet and browser, right? So on the browser, what I am doing is I just put a few keywords, right? And I don't need to install the whole data Google search engine database on my laptop. That is not needed. It will automatically go to, based on the URL, what I type www.google.com, right? And give this keyword, it will go to the URL. That means it will search the where the Google search database is, automatically it will search through the URL, go there, put this keyword in the database and fetch the information, publish on my browser. And it happens in a few click of seconds, isn't it? So that means who is working, right? Who is working of this transportation agent? Take my keywords, go there and search in database and collect the output and bring it and publish it and put it in my browser so that I can see it, right? Who is doing all this communication job? The REST API, right? So that means I need not to have a complete Google infrastructure installed on my laptop, right? Automatically REST API will just go and do the job, right? I need not to have the software loaded on my laptop, right? Only through the internet, it will go to the URL, it will search where the Google database and put my keyword, search the information and come back, right? And with a click of second, I will get that information. right? That means that is the job of REST API. REST API will automatically know what is the destination, right? It will do the job and come back, right? And it's API, right? It's a REST API, right? I just forgot the name, full form of, right? It's a REST simple state something we say, right? The full form of REST API, right? So it will automatically do the job. So we have inbuilt APIs which will do this job. You need not to have the full infrastructure loaded on your machine. So here the REST API will act as a transporter guy, right? Transportation guy who will take my commands and send it to server, get it processed, whatever instruction I've given. Let's say I want to load the image. It will go and load the image and it will collect the output and it will display. So I'll get the response. So who is doing this job? REST API. So take my command, send it to server, collect the output, come back and give it to client, right? Again, take new command and send it to server, collect the output and send it to client. So client to server, server to client. Who will do this job? REST API will do this job automatically. All right. So client to server and server to client. So this guy will do. So the architecture is very, very simple, right? So Docker engine is a client server application with these major components. What are these major components? Three components, right? Server, which is a type of long running program, right? We call a service or an engine, right? So Docker D, right? In short, or a Docker daemon, right? So Docker daemon is again a standard term, right? It is not from Docker, right? So from Linux, if you see, right, etcd or right, container D, right? All these things already there. System D, all these things we say daemon, right? So same way container daemon, right? Basically it's a service. REST API, which is basically interface that program can use to talk to daemon and instruct it what to do. So instruction will be sent what to do and who will do. This guy will pick up the instruction sent to this guy. So it will act as an interface, right, between the client and server. A command line CLI, right? A command line interface, right? Which is nothing but a Docker client, right? Through which we fire the command, right? So basically it's all inbuilt, right? I don't need a separate software. Okay, here's my Docker agent and or my Docker client and here's my Docker server. No, everything is inbuilt. Once you install Docker, Docker will bring all the components together. That's it. We don't need it. And it's not a tool. You can fire the command from anywhere, from DOS command or anything, right? It's an inbuilt layer. It will automatically talk to Docker, right? So we don't have separate tools. Everything, all these components are bundled together. When you install Docker, they are bundled together, right? So we are not worrying that where is this component, where is that component, where is their component, where is the component. No, install Docker and you are done with it, right? Only thing is you have to start the services, right, with one command, right? So that I will show you anyhow. But in Ubuntu, it is taken care. Ubuntu is a very smart operating system. All that we will talk when we do the installation, right? So the architecture is very, very simple. Right now, Docker container life cycle, right? So let's understand the life cycle, right? So as we say, we have a client to do all day-to-day job, right? And all commands we file through Docker. So Docker itself is a main command, right? And the sub command could be Docker build. If I want to do some build, I'll say Docker build. It will do the build. Build means take the source code of your customer or anything, and it will build and give you output as an image. So Docker gives always one output only, right? Wherever you have Windows, Docker installed on Windows, Linux, or any operating system, Docker output is always image, right? It will give you, it will cut an image and the output will be, right? It will do a build and the output will be image. So Docker will take the source code, do the build, and output will be image, right? We will talk about image, right? Here I will give you more information. Don't worry about it. So whatever you want. So all commands in Docker will begin with Docker. So Docker, the keyword Docker itself is our main command. So Docker build, Docker pull, Docker run. So Docker is acting as our main command. In Docker, all commands will begin with Docker as a keyword. So all the commands are begin with Docker, and the sub command could be anything: build, pull, run. These are my sub commands, right? So there are many commands, and we are not going to do any coding, right? Completely coding is not needed here, right? Not in any tool, in modern tools, even automation also don't need it, right? Through few commands we can do it, right? So here we need commands. So we have client interface. This white background is my machine where Docker is installed, right? Understand in that way, right? So we have a client. When you install Docker, you will get client. This is my main server, right? So Docker host on which Docker daemon is running, that means Docker server is running, right? So you start the Docker by starting the service, and this guy will do all the job. And then we have a registry. Registry is nothing but a repository. All right. So we have a repository where all my application images are loaded. So that means I have containerized. I have converted all my application. Traditionally, we got the installer and setup.exe, where's the CD or where's the installer, right? We used to get it, but what we have done is we have converted into an images, right? So this might be SQL image, Nginx image, right? Apache server image or whatnot, right? All the applications are into a container image, and for that we have a repository. We created a repository, right? And all the images are available, right? And this repository we call registry. We don't say repository, but slightly we say different term. We can say registry. Why we are not saying repository and why we are saying registry? Why? Because we have to register. Everybody has to register, right? So you have to register, then only you can get access, right? While upload or right, download or upload anything you want. If I want to download, I want to start a database application or engineering application, I will download. If I've created something, I'll upload it. So download and upload, push pull will do through this repository, but you have to register, right? Each and every user or a developer or a tester or a IT infrastructure guy or anybody, right? We have to register because of the metadata, right? It will create who is doing what, who is operating, who is doing what. So it will create each and every metadata information, right? So for that we have to register, and that is why we don't say repository, we say registry. So registry is nothing but a repository, right? But we have to register, so we say registry. All right, so this is the registry. Docker has its own repository, right? So if I just give you a gist of it, so like GitHub, we have Docker Hub, right? So all hub means public repository. Hub means public repository. We need not to pay anything. That is why we use hub as a terminology. GitHub, Docker Hub, right? Uh, for even for Helm also, Helm Hub, right? Many repositories are Istio Hub, many hubs are there. That means public repository. So it is hub.docker.com, right? You can register here. It doesn't need anything. It just need a valid uh, email address, right? So you can just go and do it. Just sign in because my credential already here. So once you come here, right, all the container images are here, right? Let's say I want to have MySQL database. So MySQL contain image is here. You can download it, right? So MariaDB, Percona, right? PHP, MyAdmin, right? Bitnami, MySQL, Circle, CI, MySQL, all the images, millions and millions of images are there, and you can see even the ratings also. So this image has been pulled for already, right? 4 lakhs, right? Around 87,000, right? No, sorry, 48 lakhs, right? Probably half a million, right? It's already reached, or if you can see billion rating, right? 1 billion times people have downloaded it, right? And this is the rating, right? 10K star rating is a very good rating, right? 5.4 rating, right? So 100 million, right? So 50 million, right? So you have all the right? How many people have been downloaded? It has each and everything, 50K, 500K, right? So 5 million, right? So you just name it. It has all the content image we'll be using, right? Don't worry about it. We'll be using each and everything. You just name it. We have it, kind of thing, right? So Oracle, right? Whatever application you need, you have to just come here and just type it, right? We will talk about it. I'm just giving you the sample, right? Anything. Right, so all the container images are available here, and we will talk more about it, right? Images, which operating system, official, verified, right? So all that we can take. So always take verified image and official image, right? Don't take unnecessary image. Many people they are doing and they put upload thing, right? So very verified and all that thing. We'll talk more about it, right? So this is the thing. So Docker comes with its own repository where you can directly push pull, directly, right? Pull means I want to download, push means I want to upload. So I just download and start my container, right? So we just fire, right? All day-to-day action we do through commands. So when you say Docker build, right? Who is doing this operation? Not the client. It is sending to this, and who is sending this dotted line is my REST API. REST API, as I said, will work as a transport agent, right? Who will collect my command, send it to server, get it processed, and come back with an output, right? So this is what it will do. And when physically I do, right, we will do all these things, right? So we'll see how the REST API works. I'll show you, right, when we do hands-on, right? So that time I'll show you again. So basically, this command is sent to Docker daemon. Docker daemon means Docker engine, right? So Docker build. So it will start build, right? So you give the source code, right, and you start build. So when it will build, as I told you, it will all, and this dotted line, right? This dotted line is here. This is the output, right? This command is for minus minus sign or hyphen hyphen sign, right? This is here, this hyphen sign, and this mix of both, minus dot, minus dot, minus dot, minus dot, minus dot, minus dot is these two lines, right? So don't get confused. They are different lines. So dotted means this line, right? Minus minus means this line, and combination of both these two, dot and line, dot line, dot line, dot line is here, right? So let's go with first command, docker build. When you see docker build, as I told you, Docker has its own build, own build tool, right? It has a build capability. We need not to go outside Docker and say, hey Jenkins, can you help me to do the build? We don't need Jenkins here, right? Docker, it has an inbuilt build module. Using the build module, we can build and we can get the output. What is output? Always only one output Docker gives, which is image format. So there is no confusion. Always standard output is image only, right? So if you have a source code of SQL database, you can create an image. If you have source code of any .NET or Python or anything, right, then Node.js or anything, right, we can create it. Right? How? We will do all hands-on thing. There are so many things which we'll do. So the output will be image. So it will create an image, right? Now, there are two things. One is we call container, one we call image, right? So there are two different things, right? So what is the difference between image? What is the difference between container? So just hear me out. It's very simple, but hear me out. So basically, image is your source code, right? Whenever you want to run the application, who will provide the source code? Your image will provide the source code, right? For example, in layman terms, I want to create one MS Word document, right? Or I want to create one PPT, right? For let's say Docker training, I want to create a PPT, right? What I need MS Office to be installed on my laptop. That means installer. What is the installer? MS Office. So who is the installer? Image is the installer because it brings the source code, right? It brings the source code. So image is your installer, right? And when you start MS Word or PPT, right, I have to double click on MS presentation and then the PPT application will be launched. Then I can create my presentation for training presentation or some documentation, whatever I want, I can start my work, right? And I can do. So that means I have to launch it. MS Office installation is not the only thing that you install MS Office and your work is done. No, you have to open the application, start working on the application, do whatever you want to do. Yeah, then create PPT, document, whatever you want to do, you can do, but you have to launch that application, isn't it? Same way here also, this image will bring the your application source code. That means this is your installer. And to start the application, what you do? You have to start the application. When you start the application, we call container. So how to define it, right? So the container is nothing but a running instance of your application, right? Or I say running instance of an image, right? The running instance we call container. That means when you launch MS Word to create your Word document, you have to launch the MS Word, right? You have to launch the MS Word application. Then only you can create document 1, document 2 or whatever, right? Or presentation, training presentation I want to create, I have to launch the PPT, right? MS Office is fine. It is a bundle software which is available on my laptop. I did an installation, right? So it bring all the software which are needed through MS Office installer. But the install will not create documents or PPT or anything automatically. No, I have to launch it. I have to work. So when you run the application, that is what we say container. So container is nothing but a running instance. Remember, a running instance. When your application is running mode, that time we say it's a container, right? So container is a running instance of an image or running instance of an application. We say container, right? So running instance. Remember, right? When you start working, that time we say it's a container. Otherwise, it's an image. Right? Image is just like a installer. It will bring the source code and that's it. But you have to start it, we say container, right? Now from this image, I can launch multiple container. Let's say MS Office, I can launch Word container, PPT container, MS Access database, what all comes with MS Office, I can do all that thing, right? OneNote or whatever, right? We can do all that thing. Or if I have, let's say, one application, let's say we have a database application, MySQL database, I can create multiple databases also, right? One database for one customer, another table, another table, another table, we can do it. Or in simple word, let's say MS Office, I have launched MS Word application I have launched from MS Office, right? And I can create document one for Docker, then another document for Kubernetes, another document for another for automation. Like that, I can create multiple documents, isn't it? It is not that only you create only one document. No, you can create multiple containers, right? For some customization you want here, some customization for a specific customer here, some customization here, and you can have one more, right? Once your source code is available, it doesn't matter. You can start as many as you want, right? As many containers you want because your source code is available, That doesn't matter, right? You locally, you can just go and create multiple documents. Same way we can start multiple containers. So container is nothing but a running instance of an image. Just remember that, right? And this guy just bring the source code. So all images, right? If I say Linux OS image or Oracle database image or SQL database image or JBoss server or Apache server or Nginx server, right? Anything, right? It will come into an image, and that is why you will see multiple images, right? And we also see it here, right? All these are images, right? You just name it, we get it, right? PHP, right? Adminer, right? All these are images. All right. So whenever you want to do a build, say Docker build, it will do the build and output will be always one format, that is image. Docker doesn't give multiple format. Okay, create zip or create a exe, create DLL. No, it says only image. That's it. Right. So we are going to have not too many things, only one standard format, which is image. And very soon we'll be start building our own images as well. And we will take even the ready-made images also, and we'll create our own environment coming from these images, right? Because the source code, they are source code provider. All right, they will provide the source code. So when you say pull, so it will go to the pull, right? What you have to pull, you have to mention one more, right? You have to pull Nginx or database or whatever. The Docker daemon will automatically will go to registry, because there is a hyperlink connectivity. There is one config file in which the URL of the registry is already mentioned. So it will automatically by default go to this repository and search, and it will pull the image and it will make a copy. So let's say I want to pull this Nginx, it will make a copy. So pull will do download, push will do upload. So push pull we have to use here. Push pull is nothing but download and upload. So when you say Docker pull, it will pull, that means it will download from the repository, and the config file already have a URL mentioned for the repository. So you don't need to do any configuration, and where it is mentioned, I'll show you all that thing, right? So once we install Docker, I'll show you each and everything, right? We will again revisit to this slide, right? And then we will do one-to-one mapping also. So this is what we do. And when you say Docker run, it will start the container, right? So Docker run, once you have the image, you say Docker run, it will start the container. So Docker run is basically a container command. Docker, right? Pull is a image command. It will just pull and that's it. It will not do anything, right? But when you say Docker run, it will start the container. All right, guys, any questions here? Right? So we will be doing all our day-to-day activity with these commands, and in the background, what we will be doing, we'll be playing with containers and images, containers and image. Right? Image is the thing. Without image, can you start the container? No way. So container is always dependent on image. Remember that, because who will provide the source code otherwise? You right? Once you have the source code, then no problem. Then you can do whatever you want. You can do it. Right? So that is what we will do. All right, guys.